Let's count the 1 bits inside a number. 13 in binary is 1101. If we count the ones, there are 3 of them. This count is sometimes called the population count. How do we make a computer find it without checking every single position? Here is a lovely trick. When you take n and n minus 1 and bitwise and them together, it removes exactly 1 bit, the lowest one that was set. Why? Subtracting 1 flips the lowest 1 bit to 0 and turns every 0 below it into a 1. Ending with the original then wipes that whole tail away, clearing just that 1 bit. So we keep doing n equals n and n minus 1 and count how many times we can before the number reaches 0. That count is the number of 1 bits. We start a counter at 0. While the number still has bits left, we do n and n minus 1, which clears the lowest set bit, and add 1 to the counter for the bit we just removed. When the number becomes 0, every 1 bit has been counted. Let's watch it count the ones in a few numbers. Start with a counter at 0, since we have not counted any bits yet. While bits remain, clear the lowest set bit with n and n minus 1, and add 1 to the count. Once the number is 0, return how many 1 bits we removed. Now let's test it and hit run. "13, which is 1101, gives 3. 7, which is all ones, gives 3. 8, a single 1 followed by zeros, gives 1. And 0 gives 0, just right. Here is the whole loop. Start the count at 0. While the number is still positive, clear its lowest 1 bit, add 1 to the count, and loop back. When it reaches 0, return the count. How fast is this? Each loop removes exactly 1 bit, so the number of steps equals the number of ones, not the number of positions. If there are case set bits, it takes case steps using just 1 counter, so constant space. Remember the heart of it. N and n minus 1 clears exactly 1 bit, the lowest one, each time. The loop stops the moment the number hits 0. And 0 itself has no 1 bits, so the answer is simply 0.